Hey, so welcome to my talk on building tools quickly in Unreal. I know it says blueprints, menus, utilities, and widgets, Angelscript, and more. That and more is doing a lot of heavy lifting, so we'll see how we get on. I've got a little mascot who will be helping me along the way. So I'm Paul Grieveson. I am a senior technical artist at Embark Studios. That's my Twitter handle in case you want to follow me for memes and Unreal stuff. I work at Embark in Stockholm in Sweden, and we're using Unreal on two of our projects, Arc Raiders, which we released a trailer for last year, I believe, and also for the finals, which was more recently teased and trailed on YouTube and Twitter as well. So we're using Unreal on a lot of things. It's a multi-project studio, and we use the same Unreal Engine version on both, which leads to some unique challenges. So what are we looking at today? I'm going to start with some kind of more high-level philosophy stuff, and then head into some details of like some technical things and some practical applications of what you can do with tools in Unreal, because it's a big animal. And then I'll go back up to some other stuff and come back to hopefully satisfying conclusion that some people will learn some things from. I expect a lot of you already know some of this stuff, but probably a lot of you don't know some of the other stuff. So we'll see how far we get. So my approach in general as a technical artist and tools developer is you obviously, depending on the size of the team, it might just be you, it might be a bunch of people, you want to identify the team's needs first. Like you need to be fixing an actual problem. You want to be solving something, speeding up production, saving people time, making them happier in how they work. That's an important one as well that often gets missed. And generally, because you're usually working on a production, you want to ship something, you want to solve that problem quickly. So that's what we'll be covering a lot of today. And you usually solve that by being specific. Like, you don't want to waffle around the problem or like try and think too far away from what it is that you're actually trying to solve. You just want to be specific and say, okay, these people need these things. What's the best way to do it? And then once you've got that solution, you can kind of iterate and refactor that and like improve on it. But I always prefer the idea of getting something into people's hands as soon as possible, just so that you can actually see, am I doing the right things? You don't want to spend a lot of time on something and then find out you've actually solved the wrong problem because you didn't give the thing to the people who needed it. And one of the bigger things that leads to, I think, is that when you have a larger studio or a larger team, you can kind of build an ecosystem of all the things that you're creating. And I think of this in two ways. On the one side, you've got your information, and you could be using any sort of thing like Confluence, Notion, I don't know, Google Drive, Microsoft Office, OneNote, whatever. There's a lot of tools out there. And then on the other side, you have your functionality. So like the buttons people are clicking, the data people are working with, that's all in Unreal, or it's in your DCC apps like Houdini, Maya, Blender, whatever. And you kind of want those things to feed into each other, because when they feed into each other, they reinforce each other. And there's lots of ways to do that. So I prefer looking at things as having a single source of truth. Like I say, there's a lot of apps out there, and you might use many of them, but you generally want to pick one and say, this is the thing that we're using for X. So like Notion is where we get our documentation. Jira is where we track our tasks. You don't want to start doing stuff like, oh, but we'll actually put some of the tasks in Notion, and someone else has a Trello board over there where we do some other things. Like, unless those are really disparate things, like for tracking high-level versus low-level things, I would generally recommend keeping it together. It just makes things easier, and it makes it less likely to drift information and lead to confusion, especially in larger teams. The nice thing about a lot of these tools is they give you shareable links. More modern tools have very good embedding. Like you can embed Jira links into Miro. You can embed presentations from Google Drive into Notion, and that's all inline. People can find it easily. You want to put that information where people can see it and not end up digging around for ages. And that leads to cross-pollination, like cross-linking. People can find things from one place to another, and you can actually bring that into Unreal as well. So like when you have links in Unreal, you can just jump to those in a document, and then you can actually jump back to Unreal in ways that I'll cover later. So for us at Embark, since we are a multi-project studio, we generally want to plan for sharing our tools because it just lightens the load a little bit. We do have a fairly small tech art team, but they do a lot. I know I said be specific before, and I think that's true for solving the initial problem, but you can kind of think a little bit beyond what it is that you're doing right now while you're doing it. So like if someone has asked for a specific tool, you can be like, okay, well, for this project, that's exactly what they need, but what small things can we change that will make this apply to something else or make this more reusable? And I'll cover some concrete use cases of that later. I don't think it takes much there. There's a word in Swedish, which is lagom, which basically means like just the right amount of something. And it's difficult to describe as a concept of how you think about things. Like you don't want to overthink something and spend ages trying to generalize and like make it abstract. But you also don't want to be so specific that you maybe miss a win that you could get. So it's a difficult point to know where that is. And I think that kind of comes with practice and experience and talking to your team. Because yeah, like if you don't talk to your team, you won't know if you're doing the right thing or not. If you're your own customer, great. You can close that iteration loop and just be like, what do I need? I'll do it. Is that good? Yes, I'll do some more on it, and so on. Building modularly, I think, is key to doing things quickly, because if you don't do that, you will end up with big systems that are hard to refactor, things that don't really connect very well. And again, a little planning up front goes a long way with that. You don't necessarily need to plan everything, but sometimes just sitting down and thinking or sketching for like 5-10 minutes can reveal things that will make you think about a system in a different way. So have we all seen something like this in a project? I mean, I don't like seeing it. I haven't seen one recently because of building modularly and stuff, but yeah, like this is what we want to avoid, right? No one wants to open something in Blueprint and go, well, wait, what is even going on here? How do I get from point A to point B? Is any of this stuff even reusable? It's probably not. It's all in the blueprint. So the way I think about solving this is kind of applicable to all axes of information in Unreal. It's you compose things together, right? Like if you've got an actor, you see this a lot in Unreal already. You have a lot of components that do specific things, and the way you compose behavior is this component will talk to this component. You'll have events that fire off other things. And it's the same with widgets. Like, I think Adrian actually gave a good talk on this yesterday, is like, you want to use inheritance and then also composition to build up layers of functionality in a very modular way. And it just saves you so much time when you think about this and like, well, what does this widget actually want to do? Do I need to make something specific, or am I going to reuse this somewhere else? Think about reuse a little bit. It can save you a lot of time later. And obviously, as see on the end there, it's the same for functionality, I think. Like, you generally want small functions that do something specific that you can compose into a bigger function. You don't want to just have one gigantic function that does absolutely everything, because it's not easy to refactor, it's not easy to edit, it's not easy to understand and follow. So breaking things down is really good. And again, I'll give some practical examples of this. I think that by looking at things in a modular way, you can iterate faster. And you really, like, iteration is everything in game development. Like, if you can build something quickly, you can see how it looks in an actual practical application, and then go, wait, does this make sense? Like, stubbing out methods, I do this all the time. Like, what I mean by that is you basically just create a method that takes some input parameters that you care about and create a return if you need to, which returns some other output parameters, but don't actually do anything in the function yet. Just make those inputs and outputs, and then plug them in your actual blueprints and see where, does this make sense? Can I use this somewhere else? Does this save me time? It's very, very quick to do, and it can actually save you some headaches later when you realize you've built things in the wrong way. So by doing that, you can kind of help lock down a simple API, which is more of an engineering thing. I borrowed a book called Code Complete. So I'm a technical artist. I don't have an engineering background. And I felt like I needed to learn something about engineering. And I really recommend that book. I'll link it at the end. Testing often is obviously really important. If you don't test your stuff, you won't know if it's working. If you just kind of build something and then throw it over the fence to another user, you probably find out that you missed something. So you need to test it in practical scenarios. And like I say, get it into your users' hands so that they can actually try it, show you what's wrong, talk about it, maybe even on their own machine, iterate on that. That iteration loop, to me, it kind of covers everything in game development from the highest level to the smallest level. And you want to keep that iteration loop as tight as possible. I think it's a good feedback loop. So in terms of iteration, something that we found at Embark has really helped us, and your mileage may vary on this, is we're using a Angelscript fork of Unreal. So it's a full GitHub fork. It completely replaces the base engine, so you can't use it as a plugin. So Hazelight, who are a Swedish studio as well, they developed it to help their iteration times on It Takes Two, which they released last year on multiple platforms. It's a very good game. I think it won awards. So they actually built this because it enables their designers and programmers to work more collaboratively because everything is just scripts, which gives us a lot of advantages. They also have a Discord. You can get to all of the information from that URL there. But some pros and cons to that. So I really like it because it's got hot reloading. It's much faster to write in C++. It is a script language, so it is lots of typing, but it's faster than Blueprint at runtime. Since it's text, you can diff it, you can merge it, you can do all those nice things that code does that Blueprint is more difficult to do. You can, in most cases, copy-paste code from Angelscript into C++ if you need a speed up for it. A couple of little caveats with that, but it's very easy. And it has access to some things the Blueprint doesn't. But the cons, and these are big cons, especially if you're a small team who doesn't have an engineering support like we do, it is an unsupported fork of the engine. You're at the mercy of whatever's on GitHub on Hazelight's repository right now. So do it at your own risk. I wouldn't recommend moving to this if you're halfway through a project. I would recommend, if you think you can support it, taking a look at it and evaluating if it's going to be interesting for you or not. Obviously, as a scripting language, there's syntax and stuff, so it's maybe less accessible than Blueprint, where you can just drag nodes out and connect things. It depends on the person, in my experience. Some of our artists are writing Angelscript as if they were blueprints, so it will depend on the person, I think. And it doesn't have access to a very few things the Blueprint does, like some latent actions, like delay, but I don't think anyone should be using delay anyway, so I don't mind. So here's a simple example of what a Blueprint would look like in Angelscript. This is just a really simple batch rename where we just iterate through the selected level actors and change their name to some format string with an input. So very simple thing. In Angelscript, it looks quite similar to C++. You just declare a class, which is a subclass of actor action utility, because we're just making a utility here. You implement a function, mark it as ufunction, and then just do your code there. So anyone who's written C++ and Unreal, this will look very, very familiar. Anyone who's done C# and Unity as well, it will probably look quite familiar. So I think it's quite easy to get into if you have that kind of background. But that's just a general baseline, because for me, I find that it saves me so much time working in script compared to working in Blueprint because of the benefits it gives us. On to some specific stuff. There are a lot of things in Unreal, right? It's a big engine. It keeps getting bigger every year. 5.1 added loads of stuff, like subsystems, all new things that didn't exist in 4.27 even. Lots of things to learn there. So I'm just kind of interested in if I can ask the people in the room right now to raise your hand if you are implementing things in construction script. 25%? OK. What about asset or actor action utilities? Maybe even a bit more. Interesting. Blutility buttons, just as little buttons in the details panel. Yeah, a decent amount, 50% maybe. What about asset validators? Ooh, good. I like that. Lots of people validating assets. Custom menus, icon buttons. OK, wow, that's a lot more than I expected, because those features are quite hidden. And editor utility widgets. Also good, so quite a lot of you. Good, OK, so this might not be news for a lot of people in the room, but I shall carry on and cover my examples. So you need to figure out what you want to choose, right? There are all these options, and you need to figure out which one is the best one to use. So like construction script, I'm not going to go into depth on this. I tend to avoid it, but the good thing about it is you can kind of do whatever you like into it. It's all self-contained within the actor. You can't do stuff like spawning actors or whatever, because then you'll end up with horrible things that are unmanageable. I think one of the downsides of it is you can do a lot in it, and you can end up shooting yourself in the foot, especially because not a lot of people realize that construction script runs on Cook. And a lot of people use ConstructionScript for things like doing traces and finding stuff. And then, like, if you don't have all of the levels loaded at cook time, you don't have the same context, and then things get weird. So you've got to be really careful about what you do in there. And I would say just keep everything self-contained inside the actor if you're doing ConstructionScript. And depending on what you're doing and how expensive it is, it can be better to just do that stuff through a Blutility button or a utility widget that runs in the editor, or even a commandlet if you want to do stuff at cook time. Moving on to action utilities. I love these. Our artists love these. Our designers love these. We make loads of them. The downside of these is that you end up with loads of them. And they end up in the right-click context menu. If you've got an asset action utility, it ends up in the context menu of the content browser. If you've got an actor action utility, it ends up in the context menu of the level editor when you right-click on an actor. So they're super easy to make, and I'll just do a little example of this here. And the nice thing about that is if you just sit down with some of your team, even if they haven't done much Blueprint before, you might find that they can actually make tools to help themselves. And me as a technical artist, that's great. It saves me time. So you just make them by right-clicking, make an editor utility blueprint, and then choose either actor action utility for a level editor thing or asset action utility if you want something in the content browser. So here's a simple example where I want to just remove material overrides from the actors I've got in the scene. Let's say someone has been overriding materials. I don't want that. This looks super simple, right? I've just added a blueprint function called remove material overrides on the blueprint I just created, and I just mark that function as call in editor. And as soon as I do that, that means it will get picked up by Unreal and shown in the right-click context menu. So this is a very big simplification, but this is what my function looks like. It's literally just a loop over selected actors and then call a function that removes them. And so even if anyone has never seen this before, they can just load it up and go, OK, that's what it's doing. It's getting the actors, and it's removing material overrides. They don't necessarily need to know how or why it's doing that. It's very easy to follow. So there are a bunch of things to get to that, which I'll cover in a second. But the main thing that you might want to consider here is if you have a lot of these, you want to make sure that they're only showing up in a relevant context. And I think context is really important, because otherwise people end up with weird buttons that they can click that don't do anything, which is never fun. So if you implement getSupportedClass on your action utility, it just determines whether we should show that or not. And it just returns the, I believe it's the class type. So it basically looks at your selection, checks against your function, and if the selection contains something that matches the class of the return node, it will show up. If it doesn't match the class, it won't show up. So here's an example of what ours looks like. We want to just get the selected level actors, loop over those. If any of them has a material override, we just early out and say return actor, because we want it to work on anything. This will just work on any actor that has a material override. If we go through that loop and none of them has a material override, we end up in this return node down here, where it actually returns class, which is a weird little hack because you can't have a class in the level. So that means that this will never return true for actors in the level if they don't have material overrides. So then this button just won't show up, which is kind of cool. This is a more complicated example. You could just implement something as simple as return static mesh actor, and then it will only show up if you have a static mesh actor in your selection. So that's the simple case. I optimized it a bit later because I needed to do something else. Because as we saw earlier, I had a function called getSelectedActors with overrides and modularity in mind. We just want that function to do the same thing in both cases. So I'll get into that in a minute. But this is what I end up implementing for getSupportedClass on this asset action utility. So this is where we start getting out of the action utility, and I've made a blueprint function library which contains a bunch of just static functions that just take an argument and return something. So they have no context. All they get is an input, and they give an output. And they're very minimal as well. They don't do much. It just takes an actor, returns a bool. So again, we want to keep it simple. We just get all the components that are a static mesh component. You could also use mesh component if you want to make it generic, but then other things get more complicated. We loop through those, and then we've got this magic little other static function that is actually in the same blueprint function library that just says, does this have material overrides? If it's true, we return true. Otherwise, we keep iterating through, because we don't care if all of, like if we got 100 components, we only care if one of them does or none of them do. So earlying out in this way saves us a bit of time if the first component has an override and none of the others do. So this is the actual meat of the function. This is what, if I can go back one, the has material overrides thing there, this is what this is doing. So we're actually getting the static mesh component, getting the mesh from it, getting the number of sections from the mesh, and we're basically just saying, does the static mesh component, which is the instance in the world, have the same material as the mesh originally did? And if it didn't, we return true out of here saying, yes, it has material overrides. So there's 2 early outs there just to say, like if we didn't get any static mesh at all, we just return out saying no because it doesn't have anything. And if we reach the end of the loop without coming out saying it's true, we just say it doesn't have any material overrides. So the nice thing about this is all we do from an API point of view is we just pass in a static mesh component and we get a bool. You don't actually have to understand what it's doing if you want to use that function. And you can use that anywhere because it's in a Blueprint function library. So I have exposed this function here. Actually, this could also be in the Blueprint function library because then we can use it anywhere. All it does is call the editor actor subsystem, gets the selected level actors, and then iterates through them and calls that little function that we already wrote, right? That just takes an actor and returns a bool. So if it passes that condition, we add it to an array, and then we return the array at the end. Because that now means we've got this nice little function that we can use anywhere to just say, get selected actors with material overrides, and it will give us that. And again, it just means that we've got a nice simple function that we can reuse, and it's easy to understand, it's easy to look at, and kind of all the functionality is hidden inside these smaller nodes. So here's an example of what that looks like. If we select an asset that doesn't have any material overrides, it doesn't show up. But if we right-click here on one that does, then we actually see that there's a right-click menu item called Asset Scripted Actor Actions, and Remove Material Overrides is there. And if we select something that doesn't have it, it doesn't exist. So we can just we can use that to reveal that function or not, depending on the context. And it doesn't make much sense when we've only got one, but when you've got like a library of 20 or 30 of them, you don't want them all showing up, it just gets confusing. So the nice thing about building it in this way means that if someone's like, hey, I want a little button on my actor that just removes the material overrides from the actor, I don't know why you'd want this, it's a little contrived, but this is now super easy to implement because we can just go to our blueprint, make a new function, set it as :editor, that makes it a Blutility button, and we literally just call exactly the same function because it just takes an actor, so we can just pass itself through. We didn't need to do anything else. This is now super simple. And what that looks like is we just have this little button there, and you click it, and the actor material overrides are removed. And you'll notice at no point did we have any kind of like huge spaghetti graph of things coming everywhere, because if we had built that asset action utility in one place in the blueprint, we wouldn't be able to reuse any of that stuff anywhere else. And I think that's really useful. So I didn't put any details on this because there are a couple of really good tutorials, both on the Unreal Community Wiki and also I think Alex Stevens, who used to work at Epic, posted something on Twitter. You can actually make custom menus, buttons, and add them anywhere in the Unreal UI. It just takes a name for the menu name, and then you just pass it a function to run, and it will add buttons, icons, whatever you need. And this is great for just making tools show up in context where you want them. And you can put them in multiple places as well. I generally prefer putting things more places than less, because it increases the chance that someone will find something good. Because you can't make sure that everyone knows everything all the time. It's just not possible. Helps contextualize them as well. So yeah, I've got some links at the end that people will be able to see, but I figured it wasn't worth going into here. So asset validators, I also really like these. We use them a lot at Embark because we want to keep our build stable and safe at all times. We don't want people submitting bad content. So ideally, your asset validator should tell someone how they can fix the problem that they've done. You can just put a message into the results of that. You can reuse functions from our blueprint function library that I just implemented before, and then we use them in CI. Arturo is doing a talk this afternoon in room 281 at 3:30, where he covers a little bit of this and more things about how we validate our builds. But now, with an asset validator, I can just implement this exactly the same way in one function. I can just make an asset validator and then add a call to the blueprint node that I implemented before, which is, does the actor have overrides? If it returns true, we fail the validator. If it returns false, we pass the validator. And then you get this little message log in Unreal whenever you hit save. If your asset fails validation, you will get that message saying, oh, it has material overrides. And we could write more information into the warning message there if we want to clarify the details of how to fix that, for example. But the nice thing about this is it takes like 5 seconds to make because we already have the function. We don't have to copy and paste anything. We just call it. Something that you can't do in Blueprint that you can do in Angelscript and C++, and I find this really useful for making project-agnostic tools, is there's a class called uDeveloper settings. You probably used it. I think the name is a little bit misleading because you can use them anywhere. It's not just for developers. They appear in the project settings of the editor, and you basically specify properties as being configurable properties, and then they just show up in the settings. People can set them to whatever. And I will show you how we use that in a bit. So editor utility widgets, I look at these as like the real meat of what Unreal can do as editor tools, because they're very accessible, they're very easy to make. You don't have to go into C++ or anything. They fit nicely in with the UI. You can dock them. I tend to start these by just sketching out an interface in widgets and then just try and find out what a good layout is going to be. Again, no functionality. I just want to see what data we're kind of looking at or what layout will work best. And with everything, you want to be responsive and contextual. You don't want buttons in that widget that kind of do nothing in certain scenarios. You should always try and implement like enabled states and stuff like that for just disabling parts of the UI that don't make sense in a given context. And they're very easy to create. You just right-click in the content browser, edit utilities, edit a utility widget, and then you just get a widget blueprint that you can fill up with things, right-click on it, and run it. So in this case, what I've done is I've just made a little editor utility widget that just has a text, a list view, and a button. And we're using exactly the same functions I wrote before. I've just got a timer here that ticks every, I don't know, half a second, because I didn't want it to be too expensive. And it just uses that function, which is get selected actors with material overrides that I've already written, and it's in a blueprint function library, so I just call it. And then the remove material overrides just uses that same selection and calls the same remove material overrides thing. So it's like 2 nodes that I need to implement for this. So it's actually super easy to make something like this when you've designed your initial tooling in a modular way that you can then compose. Now, I can talk about something specific, because we've actually been doing this quite a lot on our games. I don't like how that text looks. That's better. So here is our character customization editor that we use on the finals. It's basically a list view, some tools, and some information at the top. And the way I've put this together means that you can just have tabs that you can switch to view the content that you're currently looking at. So it's basically just a view on data assets. So at the very top level, it's a very simple editor utility widget. We just have a list view on the left, a header at the top, and then a kind of container for the tabs and a button for saving things. This, I find, is really good for that cross-pollination that I talked about before. We've basically got some settings where we have a gameplay tag, actually, that is, because that's hierarchical, and you can walk up the hierarchy of a gameplay tag, and you can just gather a bunch of things from a developer settings object. So we have a developer settings object called the, I think it's editor documentation settings, and you just say, for this gameplay tag, I want these URLs and these Slack channel links. And what that means is, for anyone implementing a new tool, it's very easy for them to just drop this header in, add a gameplay tag on the help documentation tag property, and it automatically builds that little list of, like, there's 2 Slack channel links, a Jira link, and a Notion link there. And so it's very easy to just implement those and call them from anywhere. So if someone else wanted to reference the same links, they just reference the same tag. And then if you want to add more links to that, you just go and edit the properties in the project settings, add links to that tag. And it'll walk up the hierarchy, so it will include everything all the way up. So we have a generic Slack channel for editor tools, for example, so that people can jump in for support directly from the tool. Also just some theming for it to make it look nice and stand out in the UI. The list view thing, this is basically just a wrapper around a normal list view. It has a filter object, which is also a modular thing, so we just have a single filter that has a very, very simple API. It just basically gets an object, and you can do whatever you like with that object and just say, does this pass the filter or not? So it's got one input, one output, and anything that passes that filter gets shown up in the list view below. Same with the sorting thing. It's just a little widget that is a standalone thing we can drop in anywhere. So if anyone wanted to add a filter for some other reason in some other UI, they can just drop a filter widget into that, and then they just set the filter class, which is just a custom object. The main thing here is just, I call it the tab widget switcher, because there is a widget switcher on Unreal, but it's just a panel with nothing on it. So this is just a wrapper that automatically adds tabs to the top of things. And again, we use this all over the place. It's a very generic widget type. It just takes a bunch of widget classes and builds widgets for them inside of it and generates the tabs for them. And again, it has simple API for like getting which tab is active and stuff like that. So, for example, to populate that tool list, here is what one of those developer settings looks like in the project settings in Unreal. You just add however many tools you want. And the nice thing about this setup is no one has to go and edit the main utility widget. No one has to touch that. This is all stored in an ini file, which is text and diffable. So all they need to do is implement a new widget and add it to this list. So it's very easy to add new tools into the character customization editor. And so the way we think about that whole API is actually super simple. Because what I wanted to do when I set this up is just make sure that all of our team can easily extend and work with this tool. Like if an animator wants to add a new tool for editing character animation specifically to an asset, it shouldn't mean that they have to learn a whole huge, complicated system. All they need to know is they have a tool that lives inside here, and the only things they need to care about are this onSelectionChanged event from the list view, which just passes through the asset we have selected, which we know is a character customization asset, because that's what the editor is. And then we have the tab widget switcher that just tells them when their tab is activated, and a save button at the bottom that just tells them that their tool should save. So there's very little for anyone to actually care about when it comes to implementing a new tool. They don't need to care about anything around this. So the API here in Angelscript is very simple. If someone wants to make a new customization editor tool widget, they just inherit from this. And the only things they really need to implement is getToolName, which just returns a text for the name of the tool that will go in the tab. And then they just need to implement something that happens on SelectionChanged, and that's where we get our item that comes in. So by doing that, you basically create a very clear framework for someone to just go, oh yeah, even if they didn't know anything about this tool before, they can see that by having those public methods, and you can do this in Blueprint as well by making a Blueprint interface or whatever, they can just see these are the things that they can do with the tool. And I don't care what they do inside any of these methods as long as they implement them. They can do what they like. All they need to know is they're getting a character customization item, and after that, whatever they want to do happens within the widget. So this gives us a very modular setup. So like the simplest example, for example, is just a details view, which just receives the character customization item and displays its properties in that view. So it's just a simple way for people to find those assets without having to go through the content browser. So actually, if we jump back to, I don't know why I'm pointing at the screen. If we jump back to this, you'll see that we actually have the front-end name, which is the localized name, and also the back-end name of the asset there. And the filter in the top left, if they type in anything, it will filter on front-end and back-end names. Because depending on who you talk to in the team, some of them refer to the back-end name because they're a designer working with that. Some of them refer to the front-end name because they're like a UI person who cares about that. And if we only display one of them, people get confused because they don't always match, right? So we want to make sure that all of the information that we display is very relevant to everyone and that we can filter on that. So, yeah, details views are great. And now I'm going to jump out a bit into going back into that ecosystem, how we connect things. So we have a tool at Embark called Skyhook, which Niels Vest developed. It's built in Python. It's open source. You can get it from our GitHub right now if you want. In Unreal, it uses the remote control API. And it basically is just a little simple layer that communicates between apps. They're just URL links that take parameters. So in our example, we have like Unreal as our main hub for developing. And then we send things to Blender. We send things to Houdini. We bring things in from Houdini. We can link from Slack or Jira. We can send or bring things in from Maya. And the way it works is basically the Skyhook app just assembles a little URL from a JSON payload. All you need is a function name, which is a string, and a dictionary of named parameters, and those can be anything. And then the server, which runs on your PC, potentially in the remote control API plugin in Unreal, just looks for that function in a Python library and then tries to execute it. So it's very, very generic, potentially even scarily generic. You can do a lot with it, and you can write the client in any language, but you do need an HTTP server to receive those links. And so this is what it looks like in practice. Someone might have messaged you on Slack with a link that you can just click, and all it does here is it actually just opens a map and sets the camera to that view because we've got a function that does that. And then they've got a different one which just jumps into the content browser and selects a specific asset. So in both of these cases, it's just a function which, hang on, I'll try and play that again because it's quite quick. You can see it's a very long and horrible URL because basically the whole URL just contains things like the map name, the camera location, all of that packed into a dictionary. And so you can just paste this into Jira, into Slack, wherever, and people can just click it and it will do stuff. You could even make it open like 20 Blueprint windows if you wanted to. The limit is just what you want to implement in Python, basically. So that is really powerful, actually, and we use that a lot for just getting things in and out of Unreal. We use that for going between Maya, for example. Like you click an animation in Maya, you can jump into Unreal for that animation, and vice versa. So I know that was a lot of stuff, and I kind of roller coasted around everywhere. Hopefully something in there was useful. I think the technical takeaways that I would say from this are like, you should just focus on the functionality first. I think it's okay if you want to build a gigantic blueprint that does everything in one event graph, but I would not leave it that way. Use the collapse down to function stuff to bring it into specific functions that do specific things, and then ideally put those into Blueprint function libraries so that you can use them from anywhere. You always want to make your tools functional and responsive, contextual and responsive, because you don't want tools just showing up in a context that doesn't make sense, right? Or allow people to click buttons that aren't going to work. I think if you are a multi-project studio or if you're working on lots of things yourself, you should try and think about how you can make your tools a little bit more agnostic, like maybe take a class a little higher level than the one that your project is using. Like if you have my project character as a subclass of character, maybe make your tools work on the character class. That might be all you need. Or work on a component basis. And obviously iterate on that a lot. Like I can't extol that enough. Like iteration is what makes things great. And the tighter your iteration loops and the better your communication with the team, I think the better your tools get. So talk to the team. Like you want feedback. If people aren't telling you things, seek them out, ask them about how they feel about the tools that they're using. Ask for specific feedback, gather bugs, fix them quickly so that people can trust that you are doing things that are helping them. And by doing that, you can build this kind of ecosystem that everyone can find data easily, jump from Unreal to documentation, jump from documentation to task tracking, jump from task tracking to DCC apps. Like the more interlinked you make that, I think the more power you get out of it. If it's hard to find things, then everyone gets confused and things slow down. I think everyone can actually build tools in Unreal with the features they provide are very accessible. And if you just want to make something small, just using an asset action utility can get you a long way. If you just want to rename a bunch of things, it's actually just 6 or 7 blueprint nodes. So I think if you ever felt like you're like, oh, I don't want to do tools, it might actually save you a bunch of time, and it might be easier than you think. And you can help your team as well by educating them. Because I think if everyone understands more about how to build things in a nice way, then you end up with a better collection of tools that you can work with yourself. So yeah, I just want to thank everyone at Embark. I think there's some of them watching on the stream. I'm going to thank my brother for lending me his copy of Code Complete, and I honestly really recommend it. It's a very well-balanced book. It's not super opinionated, because I think that's a fundamental thing in game development and software development in general. It doesn't pay to be absolutist. You want to be flexible. Sometimes you want to do something quickly and dirtily. Sometimes you want to plan it. You need to just know when to do which one. And yeah, obviously, thanks to Epic Mega Games for existing for a long time and removing the mega. So yeah, thank you very much.